Good day, learners. Today we will talk about resistors and its classifications and types. But first, let us know our most essential learning competency, which is to identify and characterize the different types of resistors. For you to have a direction, here are your specific objectives. Enumerate and describe the different types of resistors. Differentiate positive temperature coefficient from negative temperature coefficient thermistor. And finally, value the importance of resistance in the development of electronic devices like cell phones. Smartphones use a special type of resistor known as light-dependent resistor or LDR. This, together with the processor, enables your phone to adjust its screen brightness automatically. This feature not only allows you save battery power, but also protect your eyes from strain when you are using your phone at night. Now, let us proceed to our lesson proper. What are resistors? Resistors are discrete electronic components that limit the current through a circuit. Some can also be used to divide voltage. Here is an image of a common resistor. Resistors can be classified as fixed or variable resistors. We can also classify them as linear or non-linear. Under variable resistors, we have rheostat, potentiometer, thermistor, light-dependent resistor, and varistors. Under fixed resistors, we have wire-wound resistor, carbon composition resistor, film-type resistor, and chip resistor. And here are the symbols of fixed resistors and variable resistors. Let's talk about each type, starting from wire-wound resistors. Wire-wound are usually big. A wire-wound resistor is made of a special type of wire, called resistance wire, which is wrapped around an insulating core. The length of wire and its specific resistivity determine the resistance of the unit. The resistance can be less than 1 ohm up to several thousand ohms. They are available in wattage ratings from 1 watt up to 100 watts or more. Wire-wound resistors are typically used in high-current applications. There is a special type of resistor called a fusible resistor. This is a wire-wound resistor made to burn open easily when the power rating is exceeded. It then serves the dual functions of a fuse and a resistor to limit the current. Next is the carbon composition resistor. Carbon composition resistors are made of finely divided carbon or graphite mixed with a powdered insulating material as a binder in the proportions needed for the desired resistance value. They are commonly available in resistance values of 1 ohm to 20 megohms. Examples are 10 ohms, 220 ohms, 4.7 kilohms, and 68 kilohms. The power rating is generally 1/10, 1/8, 1/4, 1/2, 1, or 2 watts. Like some resistors, it has axial leads for soldering. Carbon composition resistors normally have a brown body and are cylindrical. Now let us discuss film-type resistors. Film-type resistors can be carbon film or metal film resistors. This Venn diagram shows the key differences and similarities of the two types. The resistance of carbon film depends on the ratio of carbon to insulator, while the metal film resistance depends on the dimensions of the metal film. The outer coating of the carbon film is tan in color, while metal film is coated with blue, light green, or red epoxy. But the two types are constructed in similar manner. Temperature has little effect on resistance, they both produce little noise, and their shapes are the same. In terms of precision, metal films are better. Next is the chip resistor. Surface mount resistors, also called chip resistors, are constructed by depositing a thick carbon film on a ceramic base. The exact resistance value is determined by the composition of the carbon itself, as well as by the amount of trimming done to the carbon deposit. Power dissipation ratings are typically 1/8 to 1/4 of a watt. The R2 and R3 in this computer board are the chip resistors. Chip resistor is the smallest among all types. Now we proceed to variable resistors whose resistances are affected by some factors like voltage and external factors such as light and temperature. The resistance of some types can also be changed by manual manipulation. Just like this rheostat that has an adjustable terminal. Rheostat is also a wire-wound resistor, but of variable type. This is the adjustable terminal which is equivalent to this part. You can move it this way to set the required resistance. A rheostat is a variable resistor with two terminals. It is used to vary the current in a circuit. And it is connected in series with load and voltage source. Now let's talk about potentiometer. Unlike rheostat that has only two terminals, potentiometer has three terminals. Rheostat varies the current, while potentiometer is used to vary the voltage in a circuit. While rheostat is in series with loads and voltage source, potentiometer end terminals on the other hand are connected across the voltage source. Here are the three terminals and dial knob of a potentiometer. And here is the schematic diagram showing end terminal 1, variable arm 2, and end terminal 3. Did you know that potentiometers are also called pots? Amazingly, these pots can also be used as a rheostat. Now let's talk about some special variable resistors starting with thermistors. A thermistor is a thermally sensitive resistor whose resistance value changes with temperature. This is why it is also called a temperature-dependent resistor. If the resistance of a thermistor increases with temperature, it is said to have a positive temperature coefficient or PTC. If the resistance of a thermistor decreases with temperature, it is said to have a negative temperature coefficient or NTC. Here is an NTC. The schematic symbol of thermistor is simply the schematic of variable resistor, but with letter T. Next is the light-dependent resistor. Here is the actual image of the LDR and the schematic symbol. Notice that the arrows are pointing toward the resistor symbol. The arrows represent the light. LDR is a resistor whose resistance varies depending on the amount of light falling on its surface. These resistors are often used in many circuits where it is required to sense the presence of light. Since the resistance material is a semiconductor, LDR is a non-linear type. The last type we are going to talk about is the voltage-dependent resistor or varistor. Here is an actual image of a metal oxide varistor or MOV. Varistors are voltage-dependent resistors or VDR. This means that their resistance is dependent on the voltage across them. They have non-ohmic characteristics. This means that they are non-linear type. Those are the types of resistors. Now you may take these simple tests to check what you have learned in this lesson. You can pause this video before it reveals the answers.